So this one actually starts off pretty simple, but then there's a little trick at the end of it. All right, so the first thing I want to do is notice that there are one, two, three different intercepts. And so the first intercept is -1, which means my equation will be y equals x minus 1. Because if you're going to get +1 as an intercept, it has to be x minus 1, so you add 1 to both sides and get x equals 1. The other one would be have an x-intercept of 2, so this needs to be x minus 2. And this is a 3, so this would have to be x plus 3, or sorry, x minus 3. So by having this be your three, things in parentheses, these are your three factors, you would solve each of these and get 1, 2, 3 as your intercepts. And that would be great, except when you typically think of, if you multiply all this out, this is a cubic function. Cubic functions typically look like that. This one, however, is going the other direction. It's going down, up, down. So we have to throw a negative in here so that it has a reflection around the x-axis. So the first thing is finding the three intercepts. That part's the easy part. But then noticing that this graph looks a little flipped because it's not going the typical way. And so because of that, you would need to inverse it with a negative. One thing you could do if you weren't sure about that is plug in 4. Plug in x equals 4. And if you plug that into the equation without the negative, you end up getting 6. Well, obviously it's not 6. That would be up here. So it's way down here. So that's why you need the negative to flip it. So you can sometimes use a test point to see if things are falling on your graph or not.